This is my 12.3 energy balance, energy intake, and energy expenditure. So, what is energy? Energy is defined as being a power that may be translated into motion, overcoming resistance, or causing a physical change with the ability to do work. We measure energy in both kilojoules and kilocalories when we are counting how much energy is in food. For example, 1 kilojoule makes 1,000 joules, and there are 1,460 kilojoules of energy in McCoy's crisps. So for kilocalories, it's the same, and 1 kilocalorie is equal to 1,000 calories, which means there are 250 kilocalories in crisps too. However, certain foods contain more energy when we consume them. Carbohydrates are our first source of energy and is the most vital source if you want large amounts of energy to prep us for exercise. We gain 4 kilocalories from just 1 gram. Fats are then our second source of energy once we have used those carbohydrates. This can be dangerous if we may burn too much fat, which we need for insulation and support for our bodies. We gain 9 kilocalories from just 1 gram of fat. Then thirdly, our bodies will use protein and burn muscle to gain energy, giving us 4 kilocalories per gram. So we can measure the amount of fat we have in our bodies by using 3 different methods. The first method is skin fold measurement, in which we use the caliper to measure millimeters of fat below the skin. You take these recordings from 3 up to 9 sites on the body, usually on the right side to keep consistency, by pinching the skin, so you are able to lift it up and measure the amount underneath instead of measuring the skin as well. You then add up the recordings and the sum, and it's used to create a percentage of fat on the body. This is a good way to measure body composition as it is cheap and can be done anywhere. However, the con is that it needs to be done by a professional to get the most accurate readings. Next test, the bioelectrical impedance analysis, or the BIA test, which uses a low and safe electrical current to measure fat through the body. The current will pass at will through fluids or in our muscle tissue. However, it encounters resistance when passing through fat tissue. After entering in your height and weight, a scale or handheld device is able to give you a body fat percentage. This test is useful in the way it is extremely accurate if you are hydrated. However, if you're not hydrated, then the impedance levels of which are related to water content in our tissues are not accurate. Hydrodensitometry is the final test, which weighs you in a water tank when you are fully occupied around water. You then work out the difference between your water weight and your normal weight to find out the amount of fat in your body. This is because of how fats aren't very dense and they're able to float in the water, meaning they carry no weight. So the difference in your normal weight and your underwater weight calculates the amount of fat. The pro of these is how it's very accurate. However, it's expensive to get the equipment to make it accurate. So energy balance. To describe our energy expenditure and balance, we need to know our BMR. This is our basal metabolic rate, which is our lowest rate of expenditure needed for essential functions whilst we are resting. However, there are variables that affect our BMR, such as how the rate slows as we get older due to loss of muscle tissue. But when we are younger, our metabolism speeds up. People who are generally bigger in body size have a larger BMR because of the maintenance needed for their internal organs. Taller people also have higher BMR because of the energy needed to maintain a constant temperature. Gender also differentiates the BMR, as men are typically bigger than women. They have faster metabolisms. We can finally calculate our total energy expenditure with the use of metabolic equivalent tasks, or METs. METs calculate the use of oxygen consumption per unit of body weight per minute to estimate exercise intensity. So you get the METs, you times it by 3.5, times that by your weight in kilograms. You then divide that by 200 and time that number by the duration of the exercise, or the MET in minutes. There are 3 scales which indicate energy intake versus expenditure. The first scale on the left shows how weight gain overpowers expenditure, and this is due to how you're putting on more calories in kilocalories than you're burning off. This is dangerous as you can put on weight and become obese, leaving you exposed to health problems such as heart disease and diabetes. Second scale in the middle shows how you expend more energy and calories than you're gaining. And this is dangerous as you are burning energy needed for your body to function properly, even at rest. And then the third scale shows how we balance the two, and this is the best maintenance to keep a safe and healthy lifestyle whilst exercising. So energy and sports performance. I recommended dietary allowance, or RDA, for consuming energy. For the important macronutrients are as follows. So protein, recommended 10 to 35%, fat 20 to 35%, or carbs 45 to 65%. Calorimetry is the energy expenditure that can be assessed by the measurement of heat production, and there are two types of this: indirect and direct calorimetry. Direct calorimetry measures the actual amount of heat that is produced by our bodies. This could be measured by using airtight chambers, which have coils in the ceiling that contain specific temperature water to raise humidity in the air. The athlete in the chamber, however, does have a mouthpiece so they can breathe normally. This is a good way of measuring energy expenditure, as you can see the amount of energy you expire whilst exercising in different climates. Important for readying athletes for international events where they're going to hotter climates. However, it is difficult to measure how energy was expended in colder climates, as you cannot get the chamber to freezing temperatures. Indirect calorimetry only estimates heat production by measuring respiratory gases. These gases are collected using Douglas bags whilst an athlete participates in exercise. Usually this is running on a treadmill, and then the gases are analysed by a gas analysis system. Energy consumption is calculated from the amount of oxygen that is consumed. So 1 litre of oxygen is equal to 4.8 kilocalories of expended energy. This isn't as a strong a way of testing energy expenditure, as you cannot measure how energy will be expended in different climates, and isn't as accurate due to the different climate. So it's not as accurate because of the climate compared to the other calorimetry. Body weight and mass can affect the joules we require to exercise, and this is because energy and nutrients are based around the mass. So work is done once a force is applied to a subject to move over a specific distance. The equations work, which is measured in joules, is equal to force measured in newtons times distance moved in meters, and force is equal to the kilogram of body weight of your body weight times by 10. And these equations show how many calories we burn due to how the work is measured in joules and energy. BMR, or basal metabolic rate, is done this. So to work out BMR as a male, you need to do 10 times your weight in kilograms plus 6.25 times your height in centimeters minus 5 times your age in years plus 5. Quite a mouthful. However, there are factors that affect BMR, such as gender, and this is due to how men generally contain more muscle mass, so they will have a higher BMR than females because they need more energy to function their denser muscles. Age affects BMR because as you get older and more brittle, you won't exercise as much and you will lose the muscle mass you've gained, lowering your BMR. In this case, BMR can be decreased by around 2% per decade because of age. And then climate affects BMR because of how people in hot climates use more energy to cool their body, and people in colder climates use the energy to heat themselves up more. And finally, physical exercise can make for a larger BMR due to how we can improve muscle density, and this would then mean for there to be more energy required to work. METs work hand in hand with BMR to help us estimate our daily calorific requirement. So, for example, my own total MET is 1000. This is just from walking, spin class, college work, and even sitting. And my BMR is 1860. Totaled up, this shows how I need 2860 calories a day. So for a professional trainer, Mo Farah's training schedule on a typical Tuesday requires him to do some strenuous activity. First, he does a 5-mile run to warm up, 8.5 met, followed by a 10-mile run at tempo, 12.5 met. Finished off with a 3-mile cool down run, 8.5 again. And this is just in the morning. The afternoon sees him do an hour's strength and conditioning session, which is around 6 on the Mets. Then a 6-mile recovery run in the evening, which is around a 10 Met. Overall, just from these exercises, let alone the walking and daily added on activity that he'd do, just other than these exercises, this gives my Met of around 1108. With mixed with Mo's BMR of 1540, This means that he needs around 2,648 calories a day. So 529 kilocalories of protein and fat with 1,590 kilocalories of carbohydrates. However, climate could affect this schedule due to how you may need to train in a warmer climate to ready for an event such as the Olympics in Rio, where the climate is significantly different to the UK. And this would mean that he would also need to consume more energy as he would lose more in the hot weather due to sweat and evaporation. Age could affect Mo's BMR, as when he gets older he'd be even skinnier and have less muscle mass. This would mean that he wouldn't need as much energy, but he would be able to do as much with that energy due to weaker muscles of his.